economico e sociale, perché significa, quando usi il territorio o il mare in questo modo, fare delle scelte strategiche poi sull'uso pubblico appunto di una risorsa come il mare nel nostro caso.
The special hazards of LNG spills on water appear in this experiment conducted by the Bureau at Brewston. The unconfined LNG spill vaporizes at a rate of about 1 inch per minute, or 50 times faster than on pre-cooled Earth. The flowing LNG forms a pool about 5 feet in diameter. The ignition source is located 75 feet, or 15 pool diameters, downwind. The flammable cloud of vaporized LNG ignites, and the flame flashes back along the vapor trail to ignite the LNG pool. Flattish shape of the white water vapor cloud suggests the underlying cold flammable fuel vapor spreads out faster than it rises. Accordingly, the methane sensors were positioned vertically at 9-foot intervals and horizontally at 36-foot intervals. The LNG release rates ranged up to 4 gallons per second, or 2,400 gallons over a 10-minute interval. Quite early in this investigation, the Bureau was led to study the radiation hazard created by burning LNG spills. In this experiment, the LNG vapors are ignited and burn as a lazy diffusion flame. In the prevailing mild wind, the flame never really succeeds in anchoring on the LNG pool. In other words, LNG is vaporized faster by heat transfer from the water than from the flame. This means that burning rates will necessarily be 2 to 3 times faster on water than on land, and the hazard of radiation damage will also increase. Small patches of frozen residual hydrocarbons have formed on the water and occasionally disintegrate with popping noises. These small explosions never caused concern, but early in the Bureau's investigation, a major explosion occurred that has attracted worldwide attention. This LNG spill led to an unexpected result. There was a considerable release of energy within about 1/8 of a second of the first LNG water contact. No LNG remained on the water surface, and the initial velocity of the white cloud exceeded 165 feet per second. From another camera angle, 3 or 4 discrete jets can be seen. Unfortunately, this explosion occurred with the first commercial trailer load of LNG received in Pittsburgh in '69. Because of its unexpected nature, no preparations were made for observing certain conditions that might have explained it. All subsequent efforts by the Bureau to reproduce it have failed. Many investigators have sought to interpret it. The consensus is that superheating of the cryogenic fuel results in a vapor explosion. The following sequence.
Note that a mixture with more than 40% methane will not vapor explode on contact with the water.
To assess the energy that could be released by an LNG vapor explosion, the Bureau submerged a carboy with 17 pounds of LNG to a depth of 15 feet. Rupture of the carboy underwater by means of a short length of a detonating cord produced a gas bubble that expanded and contracted 4 times as it rose to the surface. The absence of a white cloud shows that LNG vaporized completely underwater. The maximum overpressure measured at a distance of about 12 feet was about 4 pounds per square inch. The frequency of the bubble oscillations corresponds to the heating energy of 1 pound of high explosive.
Molti pensano che sia una bombola del gas di 300 metri. È falso. Un gassificatore, a differenza della bombola di casa, non è in pressione, quindi non può esplodere. In più questo impianto è sorvegliato 24 ore al giorno da rimorchiatori antincendio.
Di questa storia non è ancora scritta la parola fine. La presa di coscienza di tutti è determinante per bloccare questo affare. Sono stati promossi incontri, assemblee e convegni. In ogni occasione però è mancata la partecipazione degli amministratori pubblici, responsabili delle autorizzazioni. Perché?